So today we're going to talk about why your muscles need most of your potassium. Now, what's very unique about potassium is that it's one mineral that we need a tremendous amount of. We need 4,700 milligrams. And out of all the tissues in the body, 80% is needed by your muscles, mainly. The question is, why do we need so much, and why is it going to the muscles? But before I explain that, I need to explain something called the sodium-potassium pump. Okay? You have billions of these little pumps, and what they do is they keep potassium on the inside of the cell, and they keep sodium outside the cell. So that's their main purpose. And the reason for that is anytime you have two different minerals that are held apart like that by a pump and by a membrane, the cell wall, you create a battery, which is this. You have positive, negative, held apart. That flow of electrons, that current, generates a certain amount of energy that is stored in the battery. Well, your cells are mini batteries. In fact, your brain has about 80 billion mini battery cells. Potassium is needed as a raw material to make sure this pump works. In fact, 30% of all the energy that you have in your body is allocated to this one little pump. And because this pump allows 2 potassium in and 3 sodium out, and that difference creates a voltage. If we're talking about the muscle, we're talking about 90 millivolts. In a nerve, it's about 70 millivolts. In the skin, it's about 50 millivolts. The voltage is just the power of this battery created by the difference between these two minerals held apart. And another term for that is called membrane potential, because when it's at rest, it's like a battery, but then it gets activated and it starts releasing this electrical charge that then causes the muscle to contract. And it creates nerve impulses, and it causes glands to secrete, like hormones or even like sweat glands. The same principle happens in a thunderstorm, where you have these clouds that have a positive charge and the earth is negative. And when those clouds start building up moisture at a certain humidity, you start generating a tremendous amount of electrostatic energy. And when that electrical field gets to a certain point, it'll discharge the energy as a thunderbolt, giving off 3 million volts per meter. So that's a tremendous amount of energy that is discharged. The same thing in the cell. You have the cell wall. On the outside, you have positive. The inside, you have negative. And you have a very, very thin membrane, okay? It's like 5 nanometers. Of course, this is a very large distance right here. This is very, very tiny. But the cell wall or membrane is 2 layers of lipids or fats that keep these two minerals apart. And once the muscle is activated to contract, or the nerve is activated to send an impulse, you lose potassium. The more exercise you're doing, the more you're sweating, the more you're losing these electrolytes. If you're injured or go through a surgery or trauma, you will lose potassium. When the thyroid works, it's a gland, you'll lose more potassium. And also when you consume more refined sugar, you will also lose potassium as well. The other question is, are we losing as much sodium? No, not necessarily, because sodium has a tendency to be retained in the body, but we do lose way more potassium, and this is why this is a requirement right here. As far as the sodium requirement, it's about half what we need as far as potassium. When you do fasting, your body will have a tendency to retain more potassium just as a survival mechanism. So that's one of the biggest reasons why we have most of our potassium, 80%, in the muscles. And then when our potassium becomes low, the muscles become weak, you get tired, you don't have the endurance anymore, especially when you exercise, and your muscles start to cramp. Now, if you haven't seen my other videos on potassium, I put them up right here. Check it out.